In this video, I'm going to run Gemma 4 locally on the Jetson Orin Nano. And not just text chat, I'm going to run it with vision, upload an image, and ask the model questions about that image. Here, I gave it a waterfall image from Iceland without telling the model anything about the image. Gemma 4 was able to look at the image, reason about what it was seeing, and respond locally on the Jetson. But this did not work smoothly at first. I ran into port conflicts, CUDA out-of-memory errors, repeated model downloads, and a misleading situation where the text model worked but image input did not. The biggest lesson from all of this was simple. Check your JetPack or L4T version first. In my case, I was on L4T 36.4.7 and the vision model kept failing with CUDA out-of-memory errors. After updating to L4T 36.5, the same setup loaded successfully and both text and image input worked. So in this video, I'll do two things. First, I'll show you the clean path I recommend so you can avoid the pain I felt when setting this up. Then I'll show the actual debugging path I went through because those roadblocks would be helpful if your setup behaves differently. I also made two free one-page guides for this video. One is the clean setup path with the commands in order. The second is a troubleshooting cheat sheet with if this happens, try that format. You can get both for free on our hub at hub.learnasyouexplore.com. Let's start with the clean path. Step 1 is to check your JetPack or L4T version by checking the NVIDIA release file. If you see L4T 36.5, you're in good shape. If you see 36.4.7, I would update first before trying to run Gemma 4 Vision. This was the key issue in my setup that was causing out-of-memory errors. So this is my biggest recommendation. Check your L4T version first and upgrade if less than 36.5. If you need to update, check the NVIDIA L4T app source file. In my case, it was pointing to R36.4. I changed it to R36.5, then ran the sudo apt update command. Then I ran the sudo apt dist-upgrade command. During the upgrade, I got a couple of configuration file prompts. For the NVIDIA OEM config file, since I had not intentionally customized it, I chose the package maintainer's version by selecting Y. For the NVIDIA L4T apt source file, since I had intentionally changed it to R36.5, I kept my current version by saying N. After the upgrade finished, I checked the version. This time it showed R36 revision 5.0. Then I rebooted. After reboot, I checked again to confirm I was still on 36.5. Next, let's avoid another annoying issue: repeated model downloads. The first few times I ran this, the model and vision projector kept downloading again and again. That happened because the files were being downloaded inside the Docker container, and since I was using a temporary container, the downloaded files did not persist between runs. The fix is to mount a permanent folder on the Jetson into the container's model cache path. First, create a folder on the Jetson, and then point the Docker command to use that folder for its caching. Now here's the final command I used. Once the server starts, I open the UI from my laptop using the Jetson's local IP address. Now let's put it to the test. The plus icon in the chat bar should let you add images. I searched for an Iceland waterfall image, pasted it into the chat, and asked about it without mentioning the location. The model analyzed the image and correctly recognized that it was likely a waterfall in Iceland. That's the final working result. Gemma 4 vision running locally on the Jetson Orin Nano. Now, let me show you the roadblocks I hit before I found the clean path. This section is useful if your setup does not work right away. The first issue I hit was a port error. I ran the Docker command from the Jetson AI lab page. The container downloaded. The model also successfully downloaded, but the server failed with a port binding error. That means something was already using port 8080. To check that, I ran this lsoff command with port 8080. This showed that a process was indeed using port 8080. Then I checked Docker using the docker ps command, and I saw that an old OpenWebUI container was running. So the fix was either to stop OpenWebUI or use a different port. For this video, I chose port 8081. That got me past the port error. The next problem was the big one. CUDA out of memory. The first out of memory incident looked like this. At first, this made me think the model was simply too big. So I tried some memory cleanup steps. I dropped Linux file caches, but I still got an out of memory error. I stopped the old OpenWebUI container, and again I landed on the same error. I checked swap. The swap space existed, but wasn't actively being used. It didn't show up in the swap on show command results, so I enabled it using this command. Then I made it persistent by adding it to fstab. I also found a Gemma 4 VLA blog post, which listed some memory cleanup commands that I also tried. Even with these additional memory cleanup steps, I got the out of memory error. Then I checked memory heavy processes using this ps command. I found Ollama was running in the background, so I stopped it. I also saw gnome shell and xorg near the top, which meant the Jetson GUI was using some memory. Since I was using the Jetson remotely over SSH, I switched to terminal only mode using systemctl. That removed gnome shell and xorg from the top of the memory list. But Ollama was back. This was because I had stopped it previously but didn't disable it. I stopped and disabled it this time so it doesn't start again. After all of that, I tried Gemma 4 again, and it still failed with CUDA out of memory. That was the clue that this might not be ordinary memory pressure. Then I tried text-only mode. I added the no-mmproj flag. The model loaded successfully. That was a big clue. It meant the base Gemma 4 model could run on the Jetson. But when I loaded the mmproj file, which is the vision projector needed for image input, it failed. In the UI, I could chat with the model, but the image option was disabled and said image processing requires a vision model. That made sense because I had explicitly disabled the mmproj. So the problem was not simply Gemma 4 cannot run. The problem was specifically around loading the vision projector on my setup. Next, I wanted to rule out whether this was caused by the Docker image. I had originally used the latest Jetson Orin Docker image. I found that in the repository, there's a Gemma 4 specific version for Jetson Orin devices. Since latest can change over time, I tried the Gemma 4 specific image. That seemed like a better choice anyway because it is more specific to this model. It downloaded the container successfully and re-downloaded the models, but still failed with an out-of-memory error. I also tried a different quantized version. I tested Q4KM instead of Q4KS. Q4KS is smaller, so if this were purely a model size issue, I would expect the smaller version to have a better chance, but I tried Q4KM anyway, since that was used in the VLA demo blog post. But both failed the same way with the vision projector. I also tried limiting the context window with the -c argument, setting the context size to a small value of 2048. That did not solve it either. At this point, the pattern was clear. The model could run in text-only mode. The vision projector caused CUDA out of memory. Trying smaller quantizations, lower context size, swap, stopping services, disabling the GUI, and changing Docker images did not solve it. The next issue, more of an annoyance with the number of iterations I went through, was repeated model downloads. As you may have noticed, every time I retried the command, it downloaded the model and the mproj file again. That was frustrating because each test took several minutes. Eventually, I noticed I was mounting the wrong cache location for this container. The fix was to mount the actual model cache path. I created a directory and pointed the docker command to use that directory for its caching. After that, the model downloaded once and then reused the cache in future runs. Finally, I found this NVIDIA forum post which pointed to the root cause of all these out-of-memory errors. An NVIDIA developer mentioned that the JetPack L4T version 36.4.7 had some bugs that were fixed in a newer 36.5 version. So I checked the JetPack L4T version on my Jetson Orin Nano by looking at the NVIDIA release file, and there it was. My Jetson was on the buggy L4T 36.4.7, so I updated from R36.4 to R36.5. First, I checked the NVIDIA app source file. Then I changed the repo version from R36.4 to R36.5. Then I ran the apt update and dist-upgrade commands. During the upgrade, I got a prompt for the NVOEM config post script configuration. I chose Y to install the package maintainer's version. Then I got a prompt for the NVIDIA L4T apt source file. Since this was the file I intentionally edited to point to R36.5, I chose N to keep my current version. After the upgrade finished, I checked the version. Yay! This showed R36 revision 5.0. Then I rebooted. After reboot, I confirmed the version again. Then I ran the Gemma 4 Docker command again without disabling the vision projector, that is, keeping the vision projector enabled. Finally, it loaded successfully. No CUDA out-of-memory error. The image upload option was enabled in the UI. I pasted in an image, asked a question, and Gemma 4 analyzed the image locally on the Jetson. That confirmed the real fix. So here are my main takeaways. First, check your L4T version before doing anything else. If you are on 36.4.7 and you are getting CUDA out-of-memory errors with Gemma 4 Vision, update to 36.5 first. Second, use a persistent model cache mount, otherwise the model may download every time you run the Docker container. And finally, do not assume every CUDA out-of-memory error means the model is too big. In my case, the model fit after the L4T update. The difference between the long debugging path on the left and the straightforward path on the right is several frustrating hours. I've undergone that and wanted to share all the details here so you don't waste your time. I've put together 2 free one-page guides for this video. One is the clean setup path. The second is the troubleshooting cheat sheet. You can get them on the hub at hub.learnasyouexplore.com. And if this helped you, subscribe to Learn As You Explore for more Jetson Orin Nano, robotics, and local AI projects. Here are some of my previous videos that you'll find value in. Check those out. Until I see you in the next one.